This is AP Calculus ABA, Unit 6, More Derivatives. Lesson 6, Derivatives of Exponential Functions. So an exponential function is a function of the form, or the parent function at least, y equals a to the x. Okay? It can be 2 to the x, 3 to the x, e to the x, any number to a power. And we're to evaluate the derivative of this. Now, one of the ways in order to do this is to rewrite this as a logarithm. All right, so, or take the natural log of both sides. So I'm going to take the natural log of both sides. And we use the natural log because of a very special property, and we're going to get to that here. Use the exponent rule to move the exponent x down in front. All right, so we have ln y equals x ln a. Solving for, actually not solving for x yet, or ln a times x. Take the derivative of both sides. And here's the property that we're talking about here. The derivative of the natural log is 1 over y. And that only works for the natural log, not the log base 10 or log any other base. Okay? And it has to do with the fact that the derivative of e to the x is itself e to the x. Okay, so 1 over y, chain rule, y prime, equals, and then ln a is just a constant, right? A is just some number. The ln of some number, some positive number, is a number. So it's a constant times x. The derivative of a constant times x is just the constant. Okay? So now multiply both sides by y, and we get y prime is y ln a. Well, a little bit of substitution. Y is a to the x. So substitute that here, and we get y prime equals a to the x ln a. Okay? And so the way I remember it is this. We already know that the derivative with respect to x of e to the x is e to the x. So now in the more general case, the derivative with respect to x of a to the x is a to the x, just like e to the x, but we add in this multiplier, ln a. Okay? So if it's anything other than e to the x, the derivative of a to the x is a to the x ln a. You multiply by the ln of the base, the natural log of the base. Right? And we can use this rule to take logarithms of exponential functions and so forth and so on. Let's see, how about this example here? Let's say we have y equals 5 times 3 to the x, or let's do 2x plus 1. Okay? So y prime would be 5 times 3 to the 2x plus 1 times ln of 3. Okay, times chain rule, times the derivative of 2x plus 1, which is 2. Okay, and a little simplifying, y prime is 5 times 2, or 10, times 3 to the 2x plus 1 times ln of 3. Okay, all right, and that's it. That's kind of how it's used.